beyond the familiar worlds of the inner solar system, where we've come to know the planets and moons that accompany us on our cosmic journey, lies an entirely different realm, a vast and shadowed expanse that most of us have never seen. A place so far removed, it feels almost like another universe altogether. This is the Kuiper Belt, a region so distant, so frigid, it is barely touched by the warmth of the sun. Yet, despite its cold, despite its isolation, it holds some of the greatest secrets of our solar system, frozen in time for billions of years. This is not a place that many people think about. It's easy to imagine the planets of our solar system, Earth, Mars, Jupiter, and Saturn. But the Kuiper Belt is often forgotten. In this distant, icy frontier, the remnants of our solar system's birth still drift silently through the cosmos. These frozen bodies are the echoes of the dawn of our solar system, preserved in a state of primordial stillness. The bodies here are ancient, untouched by time. They are relics that have remained almost unchanged, carrying with them the stories of the solar system's earliest days. The Kuiper Belt is a vast region, stretching far beyond the orbit of Neptune. It is a place of wonders, a quiet zone filled with objects that are unlike anything we've encountered closer to home. Here, in the shadows of our solar system, thousands of icy bodies are scattered like pearls across an endless sea of darkness. Many of these objects are small, no bigger than asteroids, but others, like Pluto and Haumea, are large and dwarf-like, with their own moons and strange, unexpected features. Though we've known about the Kuiper Belt for decades, it was only in recent years that we began to fully understand its significance. The discovery of Pluto's moon Charon and other objects in this distant region has pushed our imaginations further than ever before. But it was not until our missions, like NASA's New Horizons spacecraft, that we began to get a glimpse of just how much this area of the solar system still hides from our view. In 2015, New Horizons made a historic flyby of Pluto, our first close-up view of the dwarf planet that had been a mystery for so long. But the excitement didn't stop there. After making its way past Pluto, New Horizons continued its journey into the deeper reaches of the Kuiper Belt. There, it discovered a treasure trove of secrets, revealing objects we had never seen before. Some of these were icy relics, while others, far more intriguing, were found to possess their own satellites, moons orbiting them in the cold vastness of space. And that's where the story becomes even more fascinating. These moons are more than just small, frozen objects. They are time capsules. They are silent witnesses to the early solar system. These tiny worlds may hold answers to questions that have eluded us for centuries. How did the solar system form? What were the conditions like when the planets and moons were first born? And can these icy moons, far from the warmth of the sun, still harbor conditions that could support life, or even provide a glimpse into the mysteries of life's origins? These moons are often small and distant, their surfaces cold and frozen, drifting in a region where sunlight is weak and the temperature is nearly absolute zero. Yet, despite their size and isolation, each one of these moons carries a story of how they came to be. Were they captured by the gravity of their parent worlds, or did they form alongside them, born from the same primordial material? What forces shaped these distant moons, and how might they have evolved in such a harsh and frozen environment? And as we study these moons, we begin to realize that many of them are far more complex than they first appear. Far from being just cold, lifeless rocks, some of these moons show signs of being geologically active. There are hints that beneath their frozen exteriors, they may harbor the same types of forces that power the volcanoes and tectonic shifts of our own Earth. Could these moons have liquid oceans trapped beneath their icy surfaces? Could they hold the key to understanding the very conditions that led to the formation of life? Take the case of Haumea, a mysterious and elongated dwarf planet that resides in the outermost reaches of the Kuiper belt. Haumea is not just remarkable for its shape, but also for the strange behavior of its moons. Haumea has two irregularly shaped moons, Hyakka and Namaka, locked in a gravitational dance. These moons are engaged in a delicate balance, tugging on one another, creating tidal forces that affect their shape and behavior. The interaction between these moons provides scientists with clues about the forces that govern the orbits of moons and the way they evolve over time. Their orbits may appear chaotic, but in that chaos lies an elegant symmetry, a cosmic dance that's been happening for billions of years. These moons of Haumea aren't just fascinating because of their peculiar orbits, they are also revealing the ways in which moons and planets interact with one another. The tidal forces at play between Haumea and its moons could offer a glimpse into the very forces that shape moons throughout the solar system. What does this reveal about the nature of gravitational interactions in the far reaches of space? How might these interactions play out on even larger scales among the gas giants of the outer planets? And then there's Makemake, another distant dwarf planet that resides in the Kuiper belt. It's cold, and it's far from the warmth of the sun, yet it, too, has a secret, a moon, tiny and frozen, orbiting it silently in the depths of space. The presence of this moon, although faint and distant, tells us that Makemake is not alone. It raises more questions than it answers. How did this moon come to be? Did it form in the same way as Makemake, or was it captured by its gravity from the surrounding Kuiper belt? And what can we learn from studying such a small and remote moon? Could it be that moons like these are more common than we think, scattered throughout the dark recesses of the Kuiper belt, waiting for us to find them? The more we learn, the more we realize that the Kuiper belt is not a barren wasteland, but a dynamic and living archive, a treasure trove of ancient worlds, moons, and mysteries. Each new discovery raises more questions. With each moon we find, we are uncovering new clues about how the solar system formed and evolved over billions of years. These moons are the solar system's forgotten children, waiting to share their stories with us. They are, in many ways, the last vestiges of the earliest days of our cosmic neighborhood. And as we continue to unlock their secrets, we are not just learning about the past, we are preparing for the future. The study of these moons may hold the key to understanding life in the most unlikely of places. Who knows what we might discover beneath their icy exteriors? Could there be signs of ancient organic molecules, or even the faintest trace of life? The Kuiper belt is a place where time stands still, a place where the mysteries of our solar system's birth are preserved in frozen silence. As we continue to explore, as our instruments and technology improve, we will inevitably peel back the layers of these ancient moons and the objects they orbit. The farthest reaches of our solar system will no longer be a dark and unexplored frontier, but a world of discovery. Each new discovery is a step forward in our understanding of the universe, a reminder that even in the coldest, most remote corners of space, there are stories waiting to be told. And in the coming years, who knows what revelations will await us? What secrets will these hidden moons reveal? What mysteries will they help us solve? For now, we continue our journey into the heart of the Kuiper belt, where the past and future collide in the icy depths of space. As we look to the stars, we are reminded of how vast and mysterious our universe truly is. And as we continue to explore the Kuiper Belt's hidden moons, we are uncovering a part of our solar system's story that has been waiting to be discovered for billions of years.